Hello students, welcome to the channel Statistica Hub. This is our lecture number 10 in the course SH201A. So this will be a very basic course and this will be like a very short lecture. This is just about application and some properties of the whatever we just covered in the module number 2 about random variables. Okay, so if I go for like what is the application of random variable? Like why do we need the random variable? So if I go for application of random variable. Okay. So while I introduced you like with the concept of random variable, I told you one thing that sometimes it may not be feasible for us to understand like how the population is like behaving. So we try to represent that particular population with the help of some sort of random variable. So the first thing that we can observe, a random variable is used to give a population, some mathematical model. That's what we can see. Okay. Moving ahead, like if we go for maybe any engineering department or maybe some medical department, like what is the use of like statistics? So we can say the random variable. So technically the use of the application, the random variables, they are like applied in different situations. So if I go for maybe engineering, you may be finding the concept of random variable. If you go for engineering, maybe the chemical decay, one kind of example, you can frame like different examples. If you go for like medical science, in that also we are going to play a major part from the random variables. Like if you have taken up any course in biostatistics, that is completely inclined on the random variables. If you go for maybe any finance kind of thing, like maybe financial engineering, maybe. So in that one also, if you have to understand something about the stocks or something like that, again, we have to introduce the concept of random variable. Okay. And if you go for like any particular example, you can frame like any particular department, anything that you can think of, maybe the job applications. Okay. Maybe the exam preparations. If you think about that one also, I can introduce some sort of like random variable that in some exam preparation, I will say that X, that is the number of hours the student are reading or studying. So this X random variable, again, that has been introduced in this particular concept. So whatever study that we take, random variables play very important part. So remember one thing, a random variable is very important in the context of in the context of studying something, uh, studying something that is having some sort of uncertainty, some sort of uncertainty. Okay, like any random phenomena that can be understood using the concept of random variables. Okay, moving ahead. Okay, I think I started writing on the last page, so I will be moving back. So if I go for the application, so in the applications part, we can think about like whatever we just covered in the last lecture. If we go for like the MGF, okay, if we go for the CGF, cumulative generating function, if you go for characteristic function, so all of them, they hold certain kind of properties, certain kind of application. So technically the MGF, like what this is holding, like this is holding some property of uniqueness, right? Like all of them, they hold the property of uniqueness. So whenever we are stuck whether this particular random phenomena that is following certain properties, some different phenomena that is following some other properties. Now we have to check whether these properties are similar or not, or these properties are same or not. So we can try to find the MGF, we can find the CGF, we can find the characteristic function. And on the behalf of that one, we can introduce that, okay, due to the uniqueness, this particular variable and this other variable, maybe some X and some Y, they are having same MGF, that means to say they are the same random variables. So that's why it is very important. MGF that can be used to find the moments. It can be used to find the cumulants. It can be used to like about the characteristic function. The most important property is that it always exists. It always exists. So just remember this property that the characteristic function, it always exists whatever distribution that you take up. Okay, if you go for the MGF, then we have to remember one property. If you are given some x1, x2, and so on some xn, okay, if they are independent random variables, I'm not saying anything about identical, I'm simply saying if they are independent And if you sum them, then the MGF of their summation x1 plus x2 plus so on some xn, let's say n observations t, this MGF that will be coming out to be simply mx1t into mx2t into so on mxn t. Remember this property. Okay. Now sometimes the MGF that plays a vital role in understanding the central limit theorem. Okay. Technically, whenever you have to prove the central limit theorem, so many times you try to introduce that, okay, this particular summation that is following the normal distribution. Now we know, if we know this particular summation that is having some certain properties. Now, if you try to find the MGF of this summation, and if this MGF is following the normal properties, like the MGF of the normal, then we know the MGF follows uniqueness property. So using that concept, you can simply introduce, or you can simply conclude that this summation that is following the normal distribution. So that is the application of like CLT. So we can take help of the MGF in the context of CLT also. Okay. About the characteristic function, we already understood that this is something that is always exists. So it plays a very vital role. It is also unique. So you can differentiate between different distributions on the behalf of the characteristic function. Okay. And technically, the characteristic functions, sorry, the characteristic functions are the, what are the characteristic functions? So the characteristic functions, they are the Fourier transformation of Fourier transformation of the probability density function. So if you go for higher mathematics or maybe higher statistics, then you may encounter these type of topics. Okay. Sometimes if you have to prove the convergence in distribution of any particular sequence of random variables, then also the characteristic functions plays a very important role. So it helps in proving convergence in distribution. So that is also an important thing. Okay. And if you go for like multivariate distributions, in course of multivariate distributions, again, the characteristic function that plays a vital role. If you have to understand something about some properties of the multivariate distributions, then we can take into consideration the characteristic function. So that will be helping us in understanding the multivariate distributions. Okay. Moving ahead with this part, if you go for like some sort of like more what we can say the combined kind of properties. So if you go for like the central limit theorem that we just covered. So if you have to prove the central limit theorem, let's say you are having some x1 and so on, some xn, these are some random variables. They are different random variables. If you sum them, then x1 plus so on xn, okay, this will be having some sort of mean, let's say mean, mu, and some variance, let's say sigma square. Okay. If I say these are IID technically, okay, note about the summation. We have to go for the summation. So if I just say about these things, they are IID with some mean mu, some standard deviation sigma. And if we have to prove that this summation Sn that is following some sort of normal distribution for large value of m, then we can make use of the MGF. So the MGF of this Sn that will be given by m Snt, that will be simply the mx of t over root of n raised to the power n. So we can make use of this property to prove that, or technically to prove the central limit theorem. So we are having a wide range of application of different things that we just covered. So the generating functions, they play very important role. So you have to focus on like how the generating functions, any of the generating function, the probability generating function, the moment generating function, the characteristic function, or the cumulative generating function. So you have to understand how these things are coming up. Okay. If you have to go for the weak low class number, maybe. So in the weak low class number also, we are having a vital role from the characteristic function. So we have to just understand like how these things are coming up. Okay, so that is the main role or the important role of all of these concepts that we just covered. So that's all about the random variables. So in the chapter random variable, we just covered in the module number 2, we just covered something about measure theory, a very basic introduction. Then we covered what is a random variable and something about the random variable. Then we covered about different types of random variable. After the types of random variable, we covered the PDF, we covered the PMF, we covered the cumulative distribution function, CDF. Then we covered something about generating functions. Okay, before that one, we just covered something about expectation and variance. Then we covered the generating function. And in this one, this is the most important part. So you have to focus on like, how do we calculate the generating function? So in this particular module, I only give the basic idea about the generating function. So in the upcoming module, when we go for different distributions, then we will try to derive different distribution, different moment generating functions for like different cases. So that will be the important part, like how do we calculate these things, that is important. And then we just went over some of the applications of the generating functions, not in very vast, but some basic introduction, like we can make use of these generating functions while calculating this thing or while calculating that. Okay, so that was all about module number 2. I hope you're able to understand the concepts about the random variable. Stay tuned. Thank you.